Hi, good morning. Welcome to today's my topic about modern physics. In the modern physics, I am going to talk about spectroscopy. What is meant by spectroscopy? Spectroscopy is nothing but study of group of frequencies or wavelengths. So here, what is the definition of spectroscopy? The study of the absorption and emission of light with other radiations by matter as related to the dependence of these processes on the wavelength of radiation. That means absorption, emission of light, radiation with wavelength characteristics. The study of the interactions between particles such as electrons, photons, and other ions like neutrinos, phonons, quarks, as well as their interaction with other particles as a function of their collision energy. It underlies crucial development in the fundamental theories of physics. It will be a fundamental and a crucial topic for the theories of physics. Uses it used in identifying the spectral lines of materials. In metallurgy, whatever materials we are using, that material spectral lines can be identified by using of this spectroscopic technique. In pharmaceutical industries, to find out trace materials. So in pharmaceuticals, to find out the trace material. It can be used to detect multidimensional elements. So multidimensional elements study purpose like carbon is exhibiting C60 form, diamond form, graphite form, hydrogen is exhibiting hydrogen form, deuterium form, tritium form. So this is nothing but multi-dimensional nature. Plastic rubber, phosphoric acid, monosulfur. So like that. Here, how the carbon is existing, say 60 form, graphite and diamond form. So this nothing but allotropic nature. So the allotropic nature of element is nothing but multi-dimensional. See the spectroscopy. In the spectroscopy, so this is a simple schematic diagram. There is a source is the emitter. So the emitter is like it is producing a particular radius that we can consider as electromagnetic radiation. The electromagnetic radiation fall on a particular sample. It may be prism or detector. Then from there it will be scattering. So from the scattering it will be collected by the spectrometer. The spectrometer is connected to the monitor or computer or any of the electronic device to analyze the spectrum. So the spectroscopy mainly involved in the absorption phenomena as well as emission phenomena. So in the absorption form, that is, so before absorption and emission we need to go to atomic spectra. When atoms are excited, they emit light of certain wavelengths which correspond to different colors. The emitted light can be observed as a series of color lines with dark spaces in between. This series of color lines is called a line or atomic spectra. What is atomic spectra? We already discussed. When atom is excited, it emits a light with a certain wavelength. The light of certain wavelength will also generate with certain colors. So the colors of we predicted on a particular background. So the colors of series can be considered as atomic spectra. So the group of frequencies in an atom is called as atomic spectra. So here there are so many colors are we can see that one color spectra. This color spectra is happening in atom, then it is called atomic spectra. See, visible region 4000 to 7000. This is about the visible region. Then in atomic spectra, so the first one is emission spectra. When hydrogen, we are going to consider hydrogen. When hydrogen is excited, why hydrogen is a monoatomic element. When hydrogen is excited under the low pressure by passing electric current, that is an external source current through it, the spectrum of emitted radiation as specific wavelength. So current is a specific wavelength. So with the specific wavelength, the spectrum of hydrogen or the hydrogen gas producing bright lines and a dark background. Bright lines on dark background. This is an emission line spectrum. This is an emission line spectrum. So here bright lines are formed on dark background. We observe that bright lines on a dark background. So this is about the emission spectra. Similarly, on passing a white light through a gas, if you pass a white light, the transmitted light shows some dark lines in the spectrum. So on the background, instead of bright lines, if dark lines are formed, then that is called as bright means emission spectra, dark lines means absorption spectra. See here, high emission lines in the spectrum of hydrogen, Lyman. So there we can see when hydrogen is emitted, so emission spectra is formed. In the emission spectra, hydrogen will form 5 different series. There are Lyman series, Bowman series, Fashion, bracket, Fund. Lyman, Balmer, Fashion, bracket, Fund. In hydrogen spectra, see the schematic diagram. When the energy level is 1, so the electron can be jumped from any energy level. It may be second, third, fourth, fifth, sixth, or infinity. If the electron jumps from any energy level to first energy level, then that series is called Lyman series. Similarly, when electron jumps to second energy level, that is an Balmer. When electron jumps to third energy level, Fashion. When electron jumps to fourth energy level, bracket, and electron jumps to fifth energy level, Fund. So like that, Lyman, Balmer, Fashion, bracket, Fund will be formed. So here, Lyman series. Lyman series included the lines emitted by transition of electron from an outer orbit of quantum number where more than 1. 1 not. 1 is the energy level, lowest energy level. So apart from 1, excluding 1, so that is 2, 3, maybe infinity, to the first orbit of quantum number 1. So the series is named after its discoverer. Who is that one? Theodore Lyman. The longest wavelength is 121.57 nanometer. The second longest wavelength is 102 line. The second 102.57 nanometer. The third longest wavelength is 97.25 nanometers. So here alpha beta from the right, alpha beta gamma to 1216. That means that is an angstrom. Here it is in nanometers. That means 1216 means 121 nanometers. Here 1026 means 102 nanometer. 972 angstrom means 97.2 nanometers. Alpha, beta, gamma. So longest one, second longest one, third longest one. Alpha is the longest one, beta is the second longest one, gamma is third longest one. Balmer series. This is formed in UV region. This is in visible region. Balmer is visible region. In 1885, Balmer observed a spectral series in the visible spectrum of hydrogen. He made the following observations. The longest wavelength is 656.3 nanometers. The second longest one is 486.1. The third one is 434.1. He also predict that the wavelength decreases, the lines appear closer together and weak intensity. So wavelength decreases, the lines appear closer. So here when lines are closer, that means they are going to be wavelength decrease. So Balmer series alpha beta gamma 656 486 431. So Readback formula, like that we can see the remaining spectra of lines, that is fashion, passion, bracket, fun, same thing. So now Readback formula, the Readback formula is a mathematical formula used to predict the wavelength of light. So the wavelength of light can be predicted by a particular mathematical formula that was introduced by Readback. Readback. So that's why it is called a Readback formula. So the Readback formula is, it is calculated when electron jumps from one energy level to another level, there is a photon of energy is generated. So by using of that condition, a Rydberg formula for hydrogen is considered as 1 by lambda equal to RH of 1 by n1 square minus 1 by n2 square, where R of H is the Rydberg constant for hydrogen. N1 is lower energy level, N2 is, that is small n, not capital N, and F2 is a higher energy level, lambda is wavelength radiation. Or H is 1.09 into 10 to the power of 7 per meter, 1.09 into 10 to the power of 7 per meter. Here is a task for you. Find wavelength of radiation of electron which jumps from energy level 3 to energy level 1, that means Lyman series. Readback equation, we know that one Readback equation is 1 by lambda equal to R of 1 by n1 square minus 1 by n2 square. So where n1 is 1, n2 is 3, where R is 1.9 into 10 to the power of 7 per meter for Readback's constant. So after putting the values, 1.0974 into 10 to the power of 7 into 1 by n1 is what? 1, n2 is 3, so 1 by 1 square minus 1 by 3 square, so 1 by lambda. So after simplification you will get 1 minus 1 by 9, so 1 by 9 equal to 975 triple 6.67 per meter, then 1 equal to 975 triple 6.67 meter per meter by into lambda, then 1 by 9754 triple 6.67 per meter equal lambda, therefore lambda equal to 1.025 into 10 to the power of minus 7 meters.